Hello everyone, my name is Philipp Bauer and today we will be talking about vibe coding done right. How AI-assisted productivity can be met with engineering discipline. I have to excuse myself today. My camera has some issues, so you have to deal with a disembodied voice today. But let's talk a little bit about who I am and what I'm doing at Code. Again, my name is Philipp, and I'm a senior software architect at Code Consulting. I have over 15 years of experience working for clients across industries, and I'm also a certified media designer. Back when I started my education in Germany, I took a little bit of a more non-traditional path into software development by going the media design route with a focus on web development and design. So if you have any questions later on, feel free to send me an email to my pbauer@codemac.com email address. And on the last slide for the Q&A section, I will also have my socials that you can reach out to me with. Let's have a quick look at Code. Most of you probably know Code already, but for those of you who don't, Code has been around for 30 years, and we have 4 different branches: the consulting, staffing, magazine, and the training branches. And combined with the experience that we have in those branches, for the last 30 years, we have been helping people build better software. A little bit about Code Consulting, just specifically. We do a lot of custom software development, everything from web, mobile, desktop, cloud platform apps. Of course, these days, a lot of Copilot development, applications with AI and GPT integrations, those kinds of things. Machine learning, all of that is nothing new to us. We still do things, more traditional things like project rescue, of course, and also app modernizations, primarily from Visual Fox Pro, but also from other systems. And of course, the usual support and maintenance for existing applications is something that we offer to our clients as well. We do have a lot of new consulting services in the AI realm. So if this is something that is interesting to you and your team and your leadership, we have executive briefings that we do with clients to help figure out what their AI needs are and what AI can do for them and what it means for them. We do a lot of pilot projects, POCs, skunk work projects, if you will. If this is something that you want to talk to us about, please feel free to reach out to us either through codemac.com/AI or the executive briefing links that you can see here. All right, let's dive right in. So imagine it's May 2027, just 2 years from now. A new developer joins your team, fresh out of a coding bootcamp. When assigned their first feature, they don't open documentation, they don't study your architecture, they simply open VS Code, activate their AI agent, and say, build me a recommendation engine that integrates with our product catalog and user profile. In under 30 minutes, functioning code appears in their pull request. A task that would have taken your senior developers days just a year ago. Your tech lead reviews the PR and discovers the code works perfectly. It follows best practices. It's optimized. It's even well commented. But there's a problem. When asked basic questions about how the algorithm works, the new developer shrugs and says, does it matter? It works, right? This is the world of vibe coding, where developers surrender deep understanding to AI tools in exchange for unprecedented productivity. A world where Microsoft's CTO estimates that 95% of all code will be AI generated by 2030. The question isn't whether this future is coming. It's already here. The question is, what does it mean for us as software professionals? What happens when coding is no longer our primary value? Today, we'll explore this tension between the extraordinary productivity of AI coding and the potential catastrophic consequences of surrendering our understanding. We'll discover how to harness these tools responsibly, without creating code bases that even their creators can't comprehend. And most importantly, we'll identify the skills and approaches that will distinguish valuable software engineers in a world where AI does most of the typing. Before we do that, I just want to gauge what is your gut reaction to AI coding tools. So please chat, let me know. Are you excited? Do you think they'll make you more productive? Or are you concerned about them, what they mean, and that they'll maybe erode essential skills? And since there is a 20-second delay, I will have to just sit here and wait. Finally, some comments come in. Useful time saver. Use it for code review all the time. Excited and concerned. Concerned that it'll overlap with their skills. Excited but a little concerned. Some both. I think being a little bit of both is a very, very good in-between to be in, to be honest. That's where I am. I'm excited about it, but I do have my concerns as well. So let's take a look at all of the items that we're going to look at today. Let's look at our agenda. First off, I will give you an introduction for those of you who don't know what vibe coding exactly is, where the term comes from, what it means. We will then take a look at the appeal and dangers of vibe coding, the evolution of AI coding tools. We'll learn how to responsibly use AI-assisted development. We'll talk about some of the new engineering skills that we'll need for this kind of software development. I'll have a short live demonstration talking about some of the things that you can use to successfully use AI tools and agents to develop your programs. And then at the end, we'll have a brief look at the future landscape and review. So, where does vibe coding come from? It's a term coined by Andrej Karpathy, a former AI leader at Tesla and co-founder of OpenAI, just recently in February 2025. It refers to a programming approach where developers, quote unquote, fully give in to the vibes, embrace exponentials, and forget that the code even exists. In his own words, he says, I accept all, always. I don't read the diffs anymore. When I get error messages, I just copy and paste them with no comment. Usually that fixes it. The code grows beyond my usual comprehension. I'd have to really read through it for a while. And sometimes the LLMs can't fix a bug, so I just work around it or ask for random changes until it goes away. So I have to couch that. He, of course, is not doing that for production environments. This is in the context of weekend development, some tools that he uses, nothing mission critical. But essentially, vibe coding represents a shift from writing code to directing an AI to write code for you, while surrendering that deep understanding of how the code actually works. Just go with the flow. This term was chosen intentionally, evoking the idea of going with the flow rather than meticulously controlling every aspect of the development. But as senior software developers, we want to use this with some programming discipline. This philosophical shift from the programmer as a craftsperson who understands every line of code to the programmer as a solution architect who provides high-level direction and requirements while the AI handles implementation is a little scary for us. So we need some frameworks around it to make that work for us, right? Before we get to how you can do that, let's look at what the current state of the technology is, where we are in this moment. Just on a higher level, and then we'll dive a little deeper. So, at the moment, the integration of AI into software development is happening at a remarkable pace across the industry. Major tech companies are increasingly relying on AI for code generation, and we're seeing productivity gains that would have seemed impossible just a few years ago. Companies like Goldman Sachs and Amazon and Microsoft and others are reporting significant improvements in developer efficiency through AI-assisted coding. These tools are making it possible for developers with limited experience in certain languages to be productive much more quickly. And they're helping experienced developers work faster than ever before. You might have done that yourself in your day-to-day, where you might be a C# developer and you needed to implement something small with Python, let's say. But you don't necessarily know Python. You understand the principles of software development, and you can just hammer out some code with AI in Python that you can probably read and understand, but you wouldn't have gotten there quite as fast without knowing the syntax or how a specific mapping function works, those kinds of things. The trend, nonetheless, is clear. AI is becoming an integral part of software development processes. And this transformation is only accelerating. We'll explore some more specific industry statistics and projections in the future landscape section at the end of the talk. So here's where the tension emerges, right? Is AI coming for our jobs? On the one hand, AI coding tools are dramatically reducing development time. They are democratizing software development, allowing non-programmers to build functional applications. And the percentage of AI-generated code is growing rapidly across the industry. So it's natural to feel that this tool is coming for us. What is going to happen in the next couple of years? Let's contrast this with the current reality of AI. We are still in the early stages, and while this is a pretty proficient tool already, there are large problems. We also know that success with AI tools requires new skills that most developers are still developing. And we also need to remember that the role of the software developer isn't disappearing, it's transforming. The skills that make a software developer valuable are rapidly evolving in this AI-assisted landscape. And while traditional programming expertise remains important, other skills are becoming increasingly essential as well. Things like prompt engineering, so the ability to communicate effectively with AI systems, system architecture, and understanding how components should work together, which AI can't easily grasp. Technical evaluations, critically assessing AI outputs for quality, security, and maintainability. Your domain expertise, to be able to provide business context and requirements that AI lacks. Problem decomposition, so breaking complex tasks into AI manageable components and correctly. And your integration expertise, connecting these AI-generated components with your existing systems and perhaps legacy code. Things like putting it into the cloud, make it actually work with the system, with the larger system that you have set up. These skills emphasize understanding over typing, vision over implementation, and judgment over rote coding tasks. So there is an appeal and there are dangers of vibe coding. I think we can all agree on that. Let me share something that genuinely surprised me some recent experience that I had. I was actually preparing for this presentation when I decided to implement a new feature for an internal platform. Kind of like going all out there. Just, use the LLM, use the agents for pretty much every piece in the process. I used an LLM to analyze transcriptions from our meetings. Then I worked with an AI to develop a project plan with phases and tasks that the AI could check off and context to operate it correctly. Together with GitHub Copilot, I created a guide for how the AI agents should implement this plan and what the code should look like. Before I knew it, I had a working version of the feature integrated into a new branch, complete with functional UI and working algorithms. The shocking part, this entire process took me about 6 hours. A complex feature that would have normally taken me a full week of work to implement. Of course, I had to make some interventions along the way, mostly when the AI didn't have all the necessary context, but really nothing that significantly slowed me down. This dramatic efficiency gain is compelling for several reasons. I'm sorry, I kind of lagged here. It's compelling for several reasons. The first of accelerated prototyping. It's crazy how you can get from an idea, from concept to a working prototype in hours instead of days. Of course, you have reduced development costs because less developer time means lower project costs. And it gives a whole new accessibility to non-programmers that can now build functional applications. So even as an experienced developer, I now find myself increasingly using AI tools, especially for tasks like converting between programming languages, especially things like Linux shell scripts to PowerShell, because I have no clue about PowerShell. I'm a Linux guy. Generating boilerplate code or implementing standard patterns, reviewing code, rubber ducking, Finally, we have a rubber duck that actually talks back. If that is something that I don't know how I feel about rubber ducks who talk back, but hey, this is useful. Anyways, the appeal of vibe coding is particularly strong for certain types of projects. Really great for throwaway weekend projects where speed trumps longevity. For projects that the New York Times author Kevin Roos, for example, demonstrated, where he created something as he quoted a software for one, a personalized tool, something that you just write and then use and throw away because you don't need it anymore. Where investment in deep understanding may not be even worth the time because it's just a throwaway thing. This is where the vibe coding approach really delivers functioning tools in a quick order. But there are hidden costs. And this convenience comes with significant hidden costs that may not be apparent until later. Things like maintenance nightmares. A developer called Namjay, he has a blog. He said that he encountered a particularly annoying bug in a payment system where the code looked clean because AI agents helped writing it. But when users started reporting issues with the payment system, he couldn't just paste the error into an AI and pray. He had to really understand the underlying payment management logic and the exact request flow to fix it. These are still boundaries where AI can support us, but it's nothing that AI could completely fix just by itself, at least not now. So when you don't fully understand the code that AI has written, maintenance becomes exponentially more difficult. Bug fixes can become trial and error exercises. Code changes can have unexpected ripple effects. Documentation can be incomplete and inconsistent. There's technical debt accumulation, that where vibe coding can lead to significant technical debt. Just Karpathy's own admission about his approach signifies this. Sometimes the LLMs can't fix a bug, so he just works around it or asks for random changes until it goes away. This is troubling. Try random things until it works. This approach epitomizes how technical debt accumulates in AI-generated code. And this debt manifests as unnecessarily complex or inefficient code, inconsistent coding styles and patterns, redundant and duplicated functionality, security vulnerabilities that remain undetected. I've seen all of this in AI's output myself. There's also, and probably one of the most important things that we need to think about, a loss of intellectual ownership. And here, Andrej, I think, really put the nail on the head, hit the nail on the head there. The loss of intellectual ownership, not understanding how your systems work. You won't be able to effectively optimize them or explain them to others. You become dependent to the AI for even minor changes. We will explore this concept of intellectual ownership in more depth in a later segment, but essentially it's the ability to reason about your system as a whole rather than just understanding individual lines of code. So when do we vibe and when do we think? So all of this is great, and it works well for throwaway weekend projects, personal utility apps, rapid prototyping, proof of concepts, non-critical tools, maybe translating from one language to another. But it is problematic for things that need to be maintained for years, production systems that are used by many people, things that need to be secure and reliable, and for things that need to be compliant with regulations and standards. Do we trust an AI completely to cover all of those things? At least, in my opinion, at this point in time, no. We do need to recognize, though, that there's an important spectrum between complete vibe coding, so accepting everything without understanding, and ignoring AI assistance entirely. The key distinction is not whether AI generated the code, but whether you understand it well enough to take responsibility for it. So, how do these tools help us? How have they evolved to become what they are today? Let's just take a quick look back to see where we come from and where we are now with the actual tools. And my focus is on VS Code. There are, of course, a whole lot of other tools available these days that are out there besides VS Code. But they all deserve their own little session, I would say, to really pick apart the strengths and weaknesses of each of them. So we'll just keep with Visual Studio Code and what they have done over the last couple of years. In 2021, they started with a technical preview for GitHub Copilot in Visual Studio Code. And this became generally available just about a year later in 2022. With it, you had a Copilot tool as it was standard for the time, which is a back and forth conversational agent with an LLM. Of course, with distinct system rules to act as a coding helper, of course. These tools already had a really good track record at generating boilerplate code, simple functions, do some, language transformations from like PowerShell to Linux shell scripts and vice versa. Those kinds of things worked really well already. Then over the next couple of years, We got more functionality with that edit function that we got in VS Code, in Copilot for VS Code. And that was that enabled us to select multiple files for context, to modify them automatically, while still remaining in control for reviews and such. Of course, better integrations with development environments followed as well with these newer versions. And really the development of large language models themselves acted as a facilitator to bring about all of these new functionalities in the tools that we use. And then officially launched, it was in 2025, just a couple months ago, that the agent mode was launched in VS Code or in GitHub Copilot. It just became generally available with the inclusion of with support for Model Context Protocol, which helps agents within VS Code, GitHub Copilot, to act independently and to choose appropriate actions to respond to the user's queries. And this speed of evolution really has been unprecedented. In just a few years, we've moved from a tool that could simply complete a line of code, a tab completion, to systems that can architect entire features or help us architect entire features and implement them. This rapid evolution mirrors the broader AI landscape, but I think has particularly significance in software development because code is both structured, making it amenable to pattern recognition, and has clear success criteria. It either works or it doesn't. This combination has made coding one of the fastest advancing applications of AI. So what are the current capabilities and limitations here? What today's AI tools can do well is, again, generate boilerplate and standard implementation patterns, convert code, debug common errors, write tests for existing code, explain unfamiliar code, and implement well-defined features. But there are persistent limitations. Again, understanding complex business domain logic, making nuanced architectural decisions, especially those with multiple competing concerns. Security-critical applications where subtle vulnerabilities could have major consequences. Optimizing for performance at scale. And maintaining consistency across large code bases over time. There are real-world examples that highlight concerning failures too. Again, when the New York Times journalist Kevin Roose experimented with vibe coding, he discovered a particularly troubling issue. In one case, the AI-generated code fabricated fake reviews for an e-commerce site. And this is especially alarming because it shows that AI not just making technical errors, but actually inventing data that wasn't provided. I think a more serious issue that raises significant reliability concerns alongside technical ones. These kinds of examples demonstrate that while AI tools are improving in some areas, they can still fail in unexpected and potentially harmful ways that go beyond simple bugs or implementation errors. And we have to have a keen eye on these kinds of things to make sure that our engineering is not suffering. Not the coding, but our engineering of software is not suffering. Because it's very new, I do want to have a quick look at the Model Context Protocol and what it does, what it is, because you might have not heard of it yet. It's a new open standard that was introduced in November of last year by Anthropic. It's often described as the USB-C for AI integrations because it enables secure two-way communication between AI models and external data sources, tools, and services. It standardizes communications, it gives you tool use, It gives you enhanced research capabilities. It's made for agent-centric architectures, and it provides you an ecosystem of components. And with that, it has certain capabilities, like the standardized communication format. Very, very important. It can automatically or autonomously discover and sequence tools. So which ones to choose and when to execute them. It has, through several integrations, MCP applications, access to real-time documentation and web search to look for things on Stack Overflow or other websites. And it can analyze your project structure and check for dependencies. The other thing that it can enable is integration with databases and query databases from within your flow. So if there is anything that is important in your data, which is otherwise not available to an agent in an IDE at all, you can build systems to enable that. All of this is great. We have all of these capabilities now, but how do we actually use AI-assisted development techniques responsibly? What kinds of things do we need to think about when we use these tools? Again, to point back at what I said earlier, one of the most critical aspects of responsible AI-assisted development is maintaining intellectual ownership of your code. This means understanding what you're deploying, even when AI has generated it. So, what is intellectual ownership? How can we define that? It goes beyond simply having your name on the code or a copyright, right? It means having a mental model of the entire system, understanding how components interact with each other and what the trade-offs are, knowing why specific approaches were chosen. That is a very critical thing, and especially something that you lose when you, for example, lose a developer in your team. There's brain drain, but you need to know the code to have brain drain. And you know, you'd be in the same situation if all of your if all of your code was generated by AI and no one understood it. You'd be in the same situation as you had a team of completely new people. If no one knows how the system actually works, you're in trouble. And you need to be able to reason about the system as a whole. So when developers surrender this understanding to AI, they do lose the ability to, as I said earlier, effectively optimize their code, explain it to stakeholders or team members, make necessary changes, and debug issues. But what are some of the signs that you lose intellectual ownership of your code? It is when you can't explain how a feature works without looking at the code. Well, if you wrote something 6 months ago, are you still really knowing how the code works? That might be debatable. But in general, if you wrote something from the ground up, you have a good sense of what it does. You find yourself making random changes to fix bugs because you don't understand the root causes. You avoid modifying certain parts of your code base out of fear because they seem very fragile. And you become dependent on AI to make even minor changes. Simon Wilson, a respected developer, made a crucial distinction here. If an LLM wrote every line of your code, but you reviewed, tested, and understood it all, that's not vibe coding in my book. That's using an LLM as a typing assistant. And I think this is a good perspective. He is the lead developer from Django, if I remember correctly, by the way. The key is not who or what generated the code, but whether you understand it well enough to take responsibility for it. So how can we gain that responsibility? How do we not lose ownership of code? And for that, we need to think about processes on our individual, team, and organizational level, right? To maintain this quality, you need a robust quality control process that is implemented and integrated into your development workflow. These strategies focus on the software development process itself. So before creating any AI-generated code, you have to start with defining expected behavior before doing that. So you can do that by describing what the feature should do in a document, create acceptance criteria, all of the little things that you would do to enable your fellow developer in a ticket tracking system to build out a new feature or fulfill a task. And that may also include creating unit and integration tests that reflect your requirements. So test-driven development principles could be used to guide an AI. You should establish architectural boundaries. Decide the structure before asking the AI to code. Create a clear project plan with well-defined functions. Define how components should interact. Specify which packages and libraries should be used and which versions are used. You could, if they are already in your project, for example, a CS project file, point at NuGet packages inside of that project file so it has a reference to what is already there. Or you type it out manually. You have to make it able to generate in small, manageable chunks. So breaking the work into small, clear steps and verify each component before moving to the next one. So instruct the large language model or the agents to work one phase at a time and stop working after so you can review what it has done, correct any issues, and then continue on with the implementation. You see already that we're using some of the things that I touched on in previous slides here. So after you receive AI-generated code, what should you do then? Do a rigorous code review. Almost literally read every line. Make sure that you don't miss anything. Verify that it meets your standards and requirements. Be certain. Make sure that it does. And very importantly, look for security vulnerabilities. Look for inefficiencies. Look for bugs. Modern AI agent systems are able to iterate automatically and look at build output. But it does get stuck sometimes. It sometimes doesn't find bugs that are already outlined in the IDE, like syntax errors, for example. Not always. But you can feed it with that information to fix those things. If it doesn't do that right away, oftentimes I would advise to manually look at what it's doing, and then even if you just see what the root cause is, let it know so it can work more efficiently for you. This is a team effort. Do comprehensive testing. Run those predefined tests that you generated or wrote yourself against the generated code. While you do that, look for edge cases that can test things based on the implementation that the AI gave you. And if applicable, perform load and stress testing on critical components. Very importantly, and this is not, of course, just for AI projects or AI-generated code and using these tools, but in general, but especially for AI-generated code, have rigorous version control discipline. Use Git or another version control system religiously. Make small atomic commits with clear messages, and the AI can help you there. It can be instructed to generate a commit when it deems its work is finished. Because AI will eventually break your code, period. You need a way to roll back, and cleanly, so it's not confusing and holding you back. If you just generate and generate and generate and generate, and you have 30 files that you have to deal with, and they all do something different or are responsible for a different piece of your implementation, it will be very hard to go back deliberately and start from a different point. There's an interesting piece of research from Deloitte that showed that over half of global organizations have prioritized enhanced testing and validation protocols specifically to address these AI-driven software development quality needs. And this focus on rigorous testing underscores the importance of ensuring AI's reliability and accuracy in the development process. So, I do recommend this human-in-the-loop approach. It's not necessarily something I came up with, but it's something that you find in different industries. It really comes from aviation, where the pilot in an airplane became that human in the loop who controls all these semi-autonomous and autonomous systems. So for us, this means that we need to act, AI for us needs to act as a collaborator, not as a commander. You decide the architecture, design patterns, and approaches. AI implements the details under your direction. You use AI for code generation, not decision making. You do continuous validation. You regularly check AI's work against your requirements. Question assumptions and implementations. Very important. Be especially vigilant with security critical code. Maybe integrate those pieces of your applications by hand. You do iterative refinement. You use AI to generate first drafts and then you refine them, with or without the help of AI. You get feedback and you use that to guide improvements. And you combine your AI-generated code with your own expertise. And then, in the end, to fill the loop, fill the hole that AI creates in our understanding of the code, we use AI to learn the new technologies or techniques that it used in its implementations. We study the generated code to understand the patterns and approaches it used. And then we document those insights gained from the AI suggestions. We make this available to the team. Ideally, we keep log of what exactly the AI did and implemented. I can imagine how you can instruct that AI to keep a running development log, so to say, that exactly lines out the steps that it took. And ideally even the commit of where it committed code into. So to implement this human-in-the-loop workflow in your workflow, again, there are these very important skills that we need to learn. Writing clear and specific prompts that include constraints and requirements. Give sufficient context about our projects. Accept only what you understand and that meets our requirements. And to use the feedback from each interaction and use our intuition and skills and experience to improve future prompts. There are some research finding that suggests that this human-in-the-loop code review process is expected to be the standard for AI automated coding tools for at least the next 2 or 3 years. Organizations are increasingly simulating how AI integration impacts code reviews across multiple roles, such as senior versus junior developers, to ensure responsibility and accountability remain with human overseers. So, of course, it's a little bit, look into a glass orb to say, this will keep up for the next 2 or 3 years. I can see this whole process evolving, and we'll get to that in a moment, where these numbers will not hold up and progress is made faster than we would expect. But that is something that we've seen repeatedly now with AI. So we'll see. But for this future, we need to think about a new software engineering skill set. And I know I sometimes repeat myself, but I need to hammer these things down because it is important. And we need to expand on these things. But as AI coding tools continue to evolve, our fundamental skills that make us successful software engineers are shifting. I had a conversation with my brother on the phone. He is also a software developer. And I noted that our talents, our talent needs will be different in the future. Currently, being a senior software engineer who understands what you're doing and you can validate what the AI produces is valuable. But I can see that these tools are evolving in the next years to the point where that might not even be necessary anymore. So just imagine we're feeding AI systems right now with how to effectively implement code, all the things that we just talked about. Now, is it possible? Can we imagine a future where all of these even higher level things are done by AI? How do we position ourselves to these kinds of developments? We need to kind of start thinking about what's in decline here, what kinds of skills are in decline, and what skills will be important in the future. And this will change. In a year, if I did this presentation again, I'd probably list other things. But as of now, what I see declining is things like just raw coding ability. It's becoming less critical as AI handles more implementation details. Even the ability to memorize syntax and language-specific details might diminish in importance. Being a specialist in a language, though, being able to optimize things on a low level, understand what AIs are doing there, that's probably still important for quite a while. But developers are now spending less time writing boilerplate and standard patterns than before, even with templates and startup scripts that scaffold a project in minutes. And debugging is increasingly assisted by AI, and it can identify and fix common issues. So what I see are skills that we need to keep and sharpen. Our skill of writing clear and detailed specifications. So the only way to actually get a good outcome is to be as precise as possible, right? And we don't have to get to the level of precision that an actual programming language delivers. But just think about the relationship with a client or with a stakeholder that wants a new feature. They have a vague idea of what they want. And we as developers are sitting there and making specific plans, and we ask the client more questions about details that they haven't told us yet. We iterate on projects, on features, and the planning on that. All of these skills will be very, very important. And we need to be able to, get better and better at it. We need to understand the limitations of different AI models. So we need to keep up with the industry. What is happening right now? When do we leverage large AI models, maybe thinking type models? When do we use smaller models? When do we use models that are not necessarily fine-tuned on coding, but on domain knowledge that we have to generate better plans with the help of AI. Those kinds of things. We'll need to be able and find ways of providing better and more appropriate context and constraints. So getting better at tooling for finding the correct information in our code base, finding the correct documentation, finding all of the things that are important for implementing a new feature, but are not immediately recognizable necessarily for an AI agent. So we need to help that along. Think about that. Think about how to do that. And we need to get better at refining our prompts. Always keep looking at what other people do, how like what makes sense for our own projects and needs, and how these details change with the large language models that we're using, how they interact with each other, because not every language model behaves the same, right? So if we have a change, if we want to switch to a new model, and we're comfortable now with Claude Sonnet 3.7, and our tooling, our prompts, everything works great with that, but then we switch to, I don't know, GPT 4.1, and it doesn't work, we need to figure out and refine these prompts. So it becomes more and more about getting comfortable writing prompts that work, and not just saying, hey, implement XYZ, but implement it with these packages, these boundary conditions, this context, this domain knowledge, all of these kinds of things. We need to get more and more proficient doing that. And this transition represents more than just a technical shift. It reflects a change in how we conceptualize the software development process. Prompt engineering is not just a skill, but a new form of literacy that bridges human intent and machine execution. The most effective developers in this new landscape will be those that can translate abstract business requirements into concrete instructions that AI can implement accurately. Understanding how different phrasings and approaches affect the quality of AI-generated code. So we shift our work from low-level coding and putting things together, putting APIs together that we use in our programs, to higher-level focus. While AI can generate code very efficiently, it does lack the ability to understand the broader context. So this creates the greater demand for skills like system architecture, right? Like project organization and workflow management. And using technologies that are based on our requirements. It continues with consistency across AI-generated components and planning for scalability and security. It also requires us to understand and use and program MCP servers, right? Building tools with that to help AI agents access information. On a project organization and workflow management level, we will need to break complex projects into chunks and AI manageable chunks, and create detailed project plans with properly named functions, acceptance criteria, all of that. We'll need to establish new or improved testing methodologies to validate AI outputs, and eventually manage teams where humans and AI collaborate. There's been a very interesting blog article that was talking about how we will eventually orchestrate many agents in parallel. So it's interesting to think about how this kind of higher level thinking comes more and more into focus in the work that we're doing. We basically all start to become, less of a coder, less of a programmer, more of an architect, a project manager. We kind of shift more from the technical role into a managerial role. I know that some people do probably feel like they will lose something doing that, instead of really being in the trenches and doing work as an individual contributor to a project. We might start to become, a different kind of programmer. That might also give us time to, and the mental space to work on hobby projects again. So we need to think about that too. Like these hobby projects then can help us keep our actual low-level skills and hone them, or maybe even, branch out, because now we have time for that. So I think that products eventually, or initiatives in an organization that focus on developing sets of instructions or ways of generating those documents for LLMs to use to generate code that are tailored to your organization, your project, your team, or whatever else will become very important, profitable even. And I think of it in a way that this change mirrors historical shifts in software development, where engineers gradually moved from low-level languages like assembly to high-level languages, with using frameworks and libraries instead of rolling all of it by yourself on your own. And each abstraction layer allowed us developers to focus on higher level concerns, right? While automation handled lower level details. And in the same way, AI represents the next major abstraction layer, but with a very crucial difference. Previous abstractions were deterministic and predictable. AI introduces variability and requires new oversight approaches. So, just to wrap this up again, and then we go into a quick demo. Here are the things that you'll have to keep in mind. Systems thinking. These are critical skills. Understanding how components interact with complex systems. Identifying potential points of failure. Designing resilient prompting techniques and architectures. Considering long-term maintenance evolution. I know I repeat myself, but these are very important things. Critical evaluation. Assessing the equality and security of AI-generated code. Identifying edge cases, recognizing when AI is operating outside of its competency, making informed decisions about when to use AI and when not to. Domain expertise, deep knowledge of your business requirements and of your user needs. The AI will not go to your user and ask them how the application performs for them. And focus groups and actual face-to-face times with people will be important. Understanding industry-specific constraints and regulations that might not be in an LLM's context or, internal knowledge. Translating domain knowledge into effective AI prompts. That's something only you can really effectively do. Validating AI outputs against domain-specific criteria. That's something that you are responsible for. And of course, the human and AI collaboration. Developing effective workflows that combine human judgment and AI efficiency. Knowing when to override or refine AI suggestions. And creating feedback loops that improve AI performance over time. And also, again, a very human thing, building teams, cultures that embrace AI as a tool rather than to replace people. So I want to take some of these principles and show how you can use them to create like a framework. And these are all just suggestions. Nothing of this is like set in stone, and you definitely need to look at all of what I'm going to show you from your own lens, from the lens of your organization, your team, your project, your current task, maybe even. Things might need to be laid out differently so they actually are adapted to what you're trying to do. There's just that sense of curiosity, of intuition that only you have, and I can't tell you what to do. So let's just take a quick look at this. Change over here. So one of the things that I came up with is a guide for humans first, to help them create a feature plan or an implementation plan for an AI. And what we will do here is not read through everything. We don't have the time for that, of course. We'll just, take a skim through this, take a look at this at a higher level. And I make this a little bit bigger, so I hope everyone can see this. So this guide outlines the process for creating a comprehensive feature plan for AI-powered functionality in your application. And you will probably see a lot of similarities to however you do your own project planning internally and how you structure these things for your ticketing system. Those MD files, yes, I will make them available. We'll probably link them in the video description later on. So begin your plan with a description of the feature and its purpose. Nothing really groundbreaking here, but make sure that you give it a lot of detail on what you want to do. Then set architectural boundaries and technical constraints. We talked about this. Let it know the technology stack. There is a specific project structure that you expect. Performance requirements, compliance requirements, a mental model of the overall, the system that the feature lives in. Define specific objectives, so concrete goals that the feature aims to achieve. This can come in very different ways, right? Acceptance criteria, user stories, all kinds of things that you could utilize to instruct the AI to generate the feature planning. Map technical foundations. Identify what is already there. Very important for the agent to understand. Like, hey, I have all of these services at my disposal. Again, context matters. Plan model extensions. So if you already have an idea of things that need to be added, new properties on a model, add them in here. Give the AI to understand, like, here, this is what we want to use, but you figure out the details. Same for maybe new interfaces that you have or that you want to amend. Develop a prompt engineering strategy. Now this is a little bit meta. It's basically the idea of instructing the agent and the LLM to how to work through a feature plan and what to use. Like, you might have internal coding guidelines that you want to add to this. These kinds of things. Development guardrails. Establish constraints that the AI-generated code must follow, kind of overlapping with the prompt templates. But coding style, naming conventions, error handling patterns, all of these things that are part of your application. You can start by analyzing your own code. If you have a project that already runs, analyze that code with the help of AI. You can use that to your advantage to extract patterns. It is a pattern matching machine, after all. It's pretty good at it. Then create a phased implementation plan. So phase 1, do these 5 tasks to, I don't know, start the project. Phase 2, implement these few tasks to create, a specific model or whatever it is. Give it a list of things to do that it can work from top to bottom. And some tips here: use checkboxes for these tasks. That's what I do. And then I instruct the LLM later in this implementation guide here. Like, after you're done with a phase, mark all of the tasks that you have done as complete. It's been pretty good with that. It's also been sometimes bad, and I could ask it to, hey, look at the code that you generated and figure out which one of these tasks you actually just completed. Define testing frameworks. Again, you could start out by using an existing unit testing framework that you already have in your application to manually create some unit tests for a specific functionality that you expected to implement. You can also have it help you create those tests. Again, it's your partner there. Use it. Maybe add some of these tests in here that you want. Validation. Design feedback mechanisms for continuous improvements. Those are more not so hard set things that the LLM might do, but then you're in the loop. Again, this is looking at your prompts and improving them, but plan for that. Include technical implementation details. That kind of goes to what we looked up earlier, like these here, but it goes to more concrete implementations of algorithms, for example, either as actual or pseudocode. You can do that. Give that logic, give these steps that you've created to the AI to actually implement. Make sure that you mention all integration points that it might need to consider. Triggers, events, data flow, all of those kinds of things. Is there a notification system? Should it send an email? Make sure all of that is covered. Address database and API impact. If you have new fields that you need in your database, this would be a place to add that. You might have specified a model earlier on or extension to a model, but there are other constraints, like your naming scheme in the database is different because it's kind of legacy, but internally you started to change it, and now you just use attributes to map those names to your fields on the model. Those kinds of things. Make sure that it understands that, and don't just leave it to chance. It may be intelligent enough to figure that out by itself, by looking at code that already exists, but it's not necessarily a guarantee. That's again, something that we maybe fix eventually by implementing more intelligent search through the code, or we have infinite context that is 100% correct all the time. I don't think that will happen, but we'll need to give it a good starting point so we set it up for success. You might want to think about resource management plans. Let it know that, hey, you're implementing an AI feature and there's a limit for tokens. Like when you set up an Azure AI endpoint for an LLM, you might have a token limit. Make it understand that there is a mechanism that controls that. Use it and adhere to, retry policies and stuff that you might already have. So all of these things, I think, there's defined acceptance criteria. A lot of things that we already talked about. This goes on, and we're running out of time, so I'm just moving ahead here. There's as well an LLM agent implementation guide that I created that is basically tasked to, take one of these feature plans and go through it bit by bit in an order. So we don't really have time to go through that. We might actually get a little bit over today. I apologize for that. I have a quick video that I want to show you of the project that we were just looking at, so there's the text analysis utility plan that you see, text analysis utility plan here. It's just working through the first phase that I defined, but I do want to show that to you real quick and let it play here. It's just it's 3 minutes. I will not even show that all. But as this goes through, so this, I basically told the agent here, use the LLM agent implementation guide, implement the text analysis utility plan, one phase at a time. So I specifically call out these guides so that it's not just floating in the context, but instructing the LLM to actually use it. Very important thing to do, because it will not necessarily adhere to this kind of stuff when you don't tell it to. What's also interesting here, as you could see, it started by creating server-client directories here. It then was already able, without even looking really, to create a new web API project using the .NET new command. What it didn't do, and you might have seen that here, or what it didn't know, was how to create a new Vue project with the latest Vite version. So it actually automatically looked that up using an MCP tool that I configured in VS Code to do a web search for this. And afterwards, as you could see, it tried to CD into the client folder, which, because it was in the server folder, didn't work, and run that test. Well, it wasn't quite clever enough here to look at the directory structure and go ahead and find that client folder it already created. I helped it along a little bit manually in the terminal there, though, by just moving one folder up. What you will see here, though, is that now it again tries to run cd and npm install here. Of course, it's already in the client folder, so it won't be able to cd into that folder. Now, this time around, though, it's intelligent enough to read the project directory structure, text analysis demo, and it sees that there is a client directory already in there. And now it modified the command here to use the absolute project directory, or the path to it, and then run npm install. So it doesn't always work out precisely as we'd expect it. It does need some hand-holding every now and then, but with these kinds of things, we already see that there are the starting points there to be pretty much 90% or more, 95% autonomous. It's very exciting. It's also kind of scary, again. By the way, here, this demonstration, I don't know if it was visible earlier, but it's intelligent enough, again, to check off the task that it finishes. Very cool stuff. All right, the last thing that we will talk about, and I probably have to switch here, is what the future holds for us. And yeah, I am conscious that we're a little over, so I will make haste. I don't want to take too much of your time. So let's take a look at the software industry and the transformation that it's undergoing right now. So this transformation really may be more profound than any previous technological shift, especially in our industry. The current trends and executive statements suggest that we're moving toward a future where AI-generated code will dominate the software development. Here are some predictions from industry leaders. Microsoft CEO Satya Nadella just recently told Mark Zuckerberg at a fireside chat that 20 to 30% of their code is currently written by using software, so AI. Google CEO Sundar Pichai reported that AI is currently generating more than 30% of Google's code. And in March of this year, Y Combinator reported that 25% of startups in their winter 2025 batch had code bases that were 95% AI generated. And this is a projection or a trajectory that even Microsoft CTO Kevin Scott recently talked about in a podcast, where he stated that he expects that 95% of all code will be AI generated by 2030. And this all isn't just speculative stuff. They represent actual trajectories of major technology companies, and technology companies that often set industry standards. So the integration of AI into software development is accelerating. It won't slow down. And as AI takes over more and more coding tasks, again, the nature of development work is shifting. It's going from implementation to architecture. The value of a developer is increasingly coming from their ability to design systems rather than implementing details. It goes from writing to reviewing, because we spend more time reviewing AI-generated code than writing code ourselves. It will go from individual expertise to team orchestration. Coordinating multiple AIs and human contributors will become a critical skill. And it will go from syntax knowledge to prompt engineering. So mastering how to instruct AI systems is replacing the need to memorize language syntax. Now, it's a craft that we want to keep, of course. And unfortunately, I already had to cut a whole section out of my talk out for time, but I was talking about strategies on how we as developers can keep our skills with this new landscape in mind, how new graduates can adapt themselves to an environment where recruiters and companies look for a very different talent set than what they learned in school, and how universities and institutions are shifting their way of teaching as well in face of AI, and how they use it to teach children and young adults to use these tools in a way where they also retain the underlying fundamentals. But unfortunately, we don't have enough time to talk about that today. So to give you a couple of strategies for success, let's just look at, again, how you can set yourself up as an individual developer, and then also as an organization. So what you need is T-shaped expertise, deep domain knowledge, and broad AI leverage. So go in both directions. Go deep in domains where you actually have intellectual ownership, where you're interested in, what you're good at. But cultivate breadth across multiple areas too, where you can leverage AI effectively. Strengthen your architectural understanding and systems thinking continually. Like that's something that you can always brush up on. There's always new things to think about. Position yourselves as a domain expert rather than just a coder, right? Focus on differentiating yourself through uniquely human skills. So all the things that AI just can't do. Like creativity and innovation that goes beyond what an AI can generate. Communication skills to bridge technical and business domains. Maintain strong ethical judgment around technology. And facilitate and collaborate skills, or build those skills to facilitate and collaborate to lead diverse teams. Upskill. Invest time in learning effective prompt engineering techniques. Develop expertise in AI model evaluation and selection. Study AI ethics, governance, and the like to position yourself for leadership roles. Build skills in collaborative development with AI assistants. And evolve yourself, evolve your personal brand. Highlight your ability to deliver a complex solution quickly using AI tools. I've already seen online in Reddit threads that people were not considered for roles because they didn't know how to use AI. Today, we're already there. So highlight your ability to deliver complex solutions. Demonstrate thought leadership. Build a portfolio that showcases that you understand it, not just an output, but showcase your understanding of things. And network in communities that focus on advanced AI development practices. Like be on that forefront. And for organizations, We need to redefine development processes that work for this AI era. We need to update our software development life cycles to account for AI-assisted development, implement proper governance for AI code generation, create clear guidelines for when to use it and when not, design performance metrics to value quality and understanding and not just speed. We need to transform talent strategy and development. We need to redesign job descriptions to emphasize architectural thinking and AI collaboration. We need to create advancement paths within our organization that, lead to people that are AI integration specialists and prompt engineers. We were kind of laughing about the idea of a prompt engineer a few years back, but this becomes a very serious role with very high compensation rates out there. Develop assessment methods that evaluate both rapid development and deep understanding. Hammer that down. If you talk to your managers, to your team leads, make sure that they understand that, yeah, you can generate all of this code, but if you don't have people that understand it, you set yourself up for failure. Also create mentorship structures that pair AI native juniors with experienced architects, people that can, complement each other and learn from each other, so that even though we might not have the influx of younger juniors that bring new ideas into a company, that we still get that benefit. And invest into organizational AI governance. This becomes a more and more important part of an organization. Already over 60% of organizations are implementing AI governance teams. You might want to establish regular audit processes for AI-generated code. A team of lead developers that regularly get together and look at what code was generated in the past week, for example. Implement, if possible, explainability and transparency tools for AI coding systems. Again, the coding log that I was referencing earlier. Have an AI document what it's doing. And create clear accountability frameworks for AI-assisted development. So make people responsible for their code. And build a future-ready technical culture. So don't just reward productivity, but code quality and intellectual ownership. Instead of just looking at productivity, look at all of the things around it too. Can they utilize new things that they discovered while vibe coding and educate other people in your organization? Those things could be rewarded. Make sure that the knowledge transfer still happens. That as a whole, you stay up to date on what's actually happening there. Encourage teams to question AI outputs rather than just blindly accepting them. Vibe coding will not be a thing for a long time, I think, where we can just blindly accept it. So encourage teams to always question AI outputs. Look for alternative implementation ways. All of those things. And also keep your own skills sharp. Celebrate innovative uses of AI while maintaining strong fundamentals. So always encourage the use of it, but also make sure that it has those fundamentals. And, create a safe space for experimentation with AI. This technology, we barely know it at this point. And there is probably a lot of things that we haven't really found yet, the ways that we can use it. So if you have a lot of people that have eyes on it, encourage them to experiment. Give them some time for that. Maybe give them, if it doesn't work out the first time and you do have to put manual labor into it, that's fine. But, be open to that. So in conclusion, and this is my last slide, so hang on just for a moment longer. Despite all of this confidence of industry leaders, and there are several important questions that still remain unanswered here. There are some uncertainties that we need to monitor. One are technical questions. How will AI tools handle increasingly complex code bases and also legacy systems? Maybe older code that LLMs are not trained on as much as C# in Python or C++ or whatever. Can it understand a COBOL system? Delphi, maybe? What will be the impact of AI be on code quality and maintainability over time? You might not already know that. Maybe organizations are, finding rifts in the development processes that they implemented that they need to have a keen eye on, and take steps to fix those. How will security vulnerabilities in AI-generated code be identified and addressed? Will we have AI-based tools that do that? Can we still rely on static evaluations of code? For now, I would definitely prefer a manual review over any AI-generated review. Like someone who understands that, we can tell the AI, look at the OWASP top 10 and make sure to not, put in a SQL injection. But those are probably not the real issues that we're thinking of. More like, unintended data access, because authentication was implemented incorrectly. And smaller things even. What are some business and career questions here? Will specialized roles emerge between AI handlers and traditional developers? What will the field be in 6 months, a year? What kinds of roles will we see? Can we specialize us? Maybe, because there is a lot of pressure in the market right now, maybe these roles are something that will help us distribute people who might, be left out at some point because AI is just doing so much of the work. We need to orient ourselves and always look out for these kinds of things. Will smaller teams with AI leverage disrupt established software companies? Who knows? Maybe some young startup will be the next Apple. How will compensation models evolve as productivity increases? But our specialized knowledge that we gained over the last decades is still valuable. So we'll have to see how all of that works out. There are educational questions. Again, unfortunately, I had to cut this for time, but how will computer science education adapt to this new reality? Let's have a look at that. Let's keep an eye on it and see what the graduates that come out of boot camps and traditional CS degrees, how will they evolve? Will those kinds of paths diverge from their current approaches? What skills remain essential? What will students have to learn in this new world? So as we consider this full landscape, it's important to return to where we began. In our opening, we explored the lure of vibe coding, right? A tempting ability to simply describe what you want and watch as AI generates the solution. We've now seen both sides of this phenomenon, the remarkable productivity gains and the concerning risks. But the truth is that neither wholesale abandonment of these tools or unquestioning adoption will serve us well. The most successful developers and organizations won't be those who either completely embrace it or reject it, but those who thoughtfully integrate it into their workflows while maintaining intellectual ownership of their systems. So just as previous technological shifts changed how we wrote code without eliminating the need for skilled developers, AI is transforming, not replacing, the core of what makes great software development possible. That is human creativity, judgment, and understanding. When used responsibly, it can help eliminate repetitive, low-value tasks, help us explore and prototype ideas more quickly, make software development more accessible, free up our mental capacity for higher-order thinking. But responsibilities demand that we maintain intellectual ownership of our systems, understand what we're deploying, apply human judgment to AI outputs, and continue to develop our fundamental skills. The coming years will bring both dramatic opportunities and significant challenges. By staying flexible, yet grounded in our fundamentals, developers can navigate the shifting landscape successfully. The coding profession isn't disappearing. It's transforming into something that may look quite different, but will still require human creativity, judgment, and understanding, as I just said. The question isn't whether AI will change software development, it's how we will adapt and evolve alongside it to create better software and more valuable solutions for our users and clients. And with that, I'm done. Thank you so much for staying longer if you did. Thanks for hanging on. There are just a few slides left that we need to go over. So if you made it to here, and I know it's been an hour and a half, you can get a free subscription to our magazine by using the link that you see here or the QR code. And of course, please share this with your friends, with your colleagues. We have our new code staffing division. New is relative now, but it's been literally disrupting the world of staffing. We're doing something that very, very few other staffing companies do. The colleagues that I have there are amazing people, all full-time employed, full compensation, benefits, all of it, without being hurried from one client and project to the next and not knowing when you sit out on the bench. So if you have any needs in your company to get some staffers that are very happy and very in the world of the code group where training is an integral part of that, go ahead and go to codestaffing.com for more information on that. And if you haven't yet and you like this video, subscribe and ring that bell for our channel so you don't ever miss any of our future content. And of course, you can, if you see this anywhere else, which you probably aren't, but youtube.com/codemag. And if you like this presentation, feel free to enter in our event survey and win $100 as an Amazon gift card. This survey must be completed by, wow, this is an outdated date. This is not the correct one. I apologize. The link is correct though. And the survey must be completed by the end of this week, this Friday, and not 2 years ago. So don't worry about that. But this Friday, which will be May 9th of 2025. So, for anyone who still wants to hang around and ask some questions, I will stick around. For everyone else who can't, if you still have questions, feel free to reach out. My presenter contact is on this slide, pbauer@codemag.com, or connect with me on LinkedIn. There, my username is Philipp J. Bauer, as you see it on this slide. Again, thank you so much for sticking it out with me. This was a very, very long presentation. I am aware of that. I hope you learned some new stuff. You have a better outlook on what this looks like. And if you're not already gone, I would like to revisit that poll from earlier. How do you feel now? How do you feel after this presentation about these tools? Are you feeling more excited now, or do you still feel more concerned, or both? Has any of that changed? I would love to hear that. And I will look out for any questions that you still have. So here we go. Thank you so much.